let me introduce myself. I'm Taisuke, coming from Tokyo. I'm currently working for the BONX Android app development, which is a real-world example of Android Akka in this talk. And also, I'm doing a kind of technical advisor for the Step 10 Original Inc., which is one of the autotech giant in Japan. And also, I'm organizing a Scala Days Conference for around 5 years. Scala Days Conference is the largest international conference in Asia, welcoming 550 to 600 participants. We ordinarily have the CFP and subsequent voting session to determine which session will be accepted. With this voting result, we would offer some travel support budget for highly voted speakers if they want. And we have the bidirectional professional translation services, so you can enjoy even Japanese sessions as well. And we have usually a sushi lunch or dinner every year. And next will be around March next year, but it's not fixed yet. Okay. So now let me back to the talk. So it's totally about a VoIP client use case. Are you familiar with VoIP system? Okay. Oh, great. Some raise your hand. Okay. By the way, the VoIP stands for the Voice over Internet Protocol. It's kind of a system for the conversation via internet, like Line or WhatsApp or other kind of application. And so in this talk, at first, I'd like to show you a demo about a very simple VoIP system, and then I'll go to the real-world example. Then I'll do rationale, why I use Android Akka with how Scala is working in Android explanation. And then at last, I'd like to cover the pros and the cons of the Scala Android and Akka. Okay, let me first show you a demo. Okay, I published that source code of this demo. And this project consists of the two parts. One is the client, which means the Android application, and another is the server. Actually, in this kind, client server is important. Okay. Let me build and install the Android application first. Just the Android run command is command to run. Okay. Okay, you can see it. Okay. In this app, you can specify the IP address of the server and the port. Then you can run the server project with IP address which is bound to and the port which you'll be listening to. We have two types of the server. The one is echo and the one will be the VoIP. It's for the conversation. For this, let me use the echo server. Then connect to it, and let me turn on the mic. Hello. Okay, you can hear me. Totally very simple. It would be the simplest example of the VoIP, but you can have a sense what I'm going to create. Okay. Then next, what is a real-world example? Which name is BONX. That is a group talk system for outdoor activities such as snowboarding, skiing, fishing, or cycling. During the activities, you can talk with the friends always. That is so you can share your experience in real-time basis. That will be definitely fun. So BONX system consists of three parts. The one would be the apps for Android and iOS. Another would be the servers. We have two types of server, API and VoIP server. And last one would be the unique things for the BONX, that we have a special Bluetooth headset which made by ourselves. In this talk, we'll cover only the Android part, because only that part is implemented in Scala. Okay, so why use Android Akka for that application? So two rationale why I do. So let me specify what is the requirements of the system. Okay, at first, VoIP system is generally the stateful, asynchronous stream processing type of system. This means it has two types of the streams, which is upstream and downstream. In upstream, first, your voice is captured in the recorder module from the mic, and that data will be sent to the DSP module. DSP stands for the digital signal processing. For example, in BONX, that a certain DSP module detects the voice activity, okay, what is the human voice is, and only the human voices are sent to the subsequent modules. And also, we standardize the volume of the mic. And then that processed audio data will be sent to the encoder and encoded to minimize the voice packets, and it will be sent to the server via socket. The other user, who is connected with same room, will receive the voice data via socket, and that data will be decoded, and it might have the additional DSP, and then played for the speaker. So these modules in upstream and downstream have their own state. And typically, they are unsafe. That's why we need a smart way to manage that kind of really stateful concurrent programming. And also, the BONX must be resilient because in outdoor activities, we must handle the tons of errors. Like, for example, please imagine you are walking around in mountain. So some part of the mountain clearly don't have the network. So you go out of range, and then you will be disconnected with the network, and then it will be recovered afterwards. So, and also you might face some hardware I/O errors because outdoor activity typically long-lasting, like 6 hours at once. And so we have the Bluetooth headset, so it might be disconnected sometimes. So if these kind of components have a problem, it should be recovered in background, because in these kind of activities, user cannot see the smartphone, cannot manipulate. That's why it should be recovered automatically. That's why I say it must be resilient. Even worse, the errors might be discovered in a downstream of the root codes. For example, some DSP module find the errors, but it was caused by the broken audio data. So broken audio data might be produced by the broken audio driver. If that's the case, the root cause is in the recorder rather than that DSP module. So this kind of error have to be back propagated, and the root cause has to be fixed. And this kind of broken audio data might spoil the user's experience, because this might lead to some noise. So what if the recorder has to be fixed? Then the subsequent cues, which might have some broken audio data, have to be disposed. So as a summary, two types of requirements we have. The first is stateful concurrent programming, and the other is resiliency with some customization. So it's where Akka comes in. Akka, as you know, is a toolkit for concurrent programming and resiliency and distributed system. The last one would be out of scope in this talk. It works great for the stateful concurrent programming because Akka is providing the message-driven actor model, which is great because an actor encapsulates its state unless it exposes explicitly. And as I show the next sample code, so the actor retrieves and processes a message from its mailbox one at a time. This is quite important. So a message is running one at a time. This means you don't need to worry about explicit lock. Even the state encapsulated in actor is unsafe. So as you can see, this example is pretty straightforward, but it works. Okay, next. Akka makes a system resilient. Why? Akka handles exception very well in two ways. One would be the actor hierarchy. Each actor can have its own children. And the parent actor gets notified once a child actor throws an exception. And the supervisor strategy function in parent actor can decide how to behave the child actor after the exception, restart, stop, or resume. If you specify restart, then that child actor will restart with keeping the messages in it. And another one would be monitoring. I'd say it's like cycle watching or death watch. Every actor can watch other actor, then the watcher actor gets a terminated message once a watchee actor is stopped. So, and then, so you can recreate that actor if you want. The key point is this kind of recreation of actor disposes all messages in it. This is the difference from the supervisor strategy. So you can choose depending on the situation. This is another example of the exception handling by actor. So please see the create child actor first. In this function, just creating a child actor, and the parent actor watch the child actor, and then in the receive function, it can receive the terminated message once the child actor is terminated. In the supervisor strategy, if the child actor throws broken audio data exception, it stops the child actor because it wants the child actor dispose all the messages. Broken audio data should not be played, so it has to be disposed. In the other exception, just escalate into the grandparent actor in this sample. But you can choose how it should behave. Okay, now let me recap how Akka works great in this example. As for the stateful concurrent programming, actor state encapsulation, and the processing a message one at a time. So we need not to worry about explicit lock, even though it's threat unsafe. And about the resiliency, actor hierarchy or monitoring means this death watch handles errors as you like. So Akka solves VoIP problems almost. Why do I say almost? Because some problems can't be captured by exceptions. For example, the audio driver might get silenced, might get blocked sometimes, and doesn't respond to anything. It doesn't throw any exception. This is annoying. And if you face this kind of situation, it might not be a silver bullet. So what I'm doing is ask a message into the that actor might be silenced, and check if the act will be returned within a timeout. If the futures get timeout, stop and recreate that actor. So actually, this kind of heuristic approach I'm doing. Actually, this is okay. So as a disclaimer, this kind of heuristic approach is not often recommended. So please first consider if you can capture it as an exception, or just eliminate the cause of the blocking. It will be the first option. Okay, the next, let me explain how Scala is working in Android. Okay, from the build to chain point of view, okay, as you know, so Scala compiles Scala source codes into Java bytecodes. And in Android SDK, there is a DEX tool which translates the Java bytecodes into Darbic executable bytecodes. So by the way, Darbic is a VM in Android. With these tools, you can see the Scala source codes will be translated into Darbic executable code eventually. And you don't need to use them directly, as the SBT Android plugin is already there. It is awesome. It is almost functionally compatible with the Android standard build system, as well as it works great with other SBT plugins like a built-in plugin, which I like. From the device specs point of view, Android device specs are already good enough. For example, in this couple of days or couple of years, flagship Android devices have around 4 to 10 CPU cores, as well as 3 to 4 gigabyte memories. Per VM basis, you can use up to around 500 megabytes memory if you specify the large heap tool configuration. So I would say it's good enough for Akka as well. So now, you might know the Android Scala is working in the production. So the next question would be, should you use Scala in Android? However, I'm not insisting to say that Scala is the best language for Android, because it clearly has trade-offs. So I'd cover the pros and the cons rather than just, hey, let's use Scala for Android. Okay, pros. Scala is obviously the powerful language fit and a rich standard library, as well as ecosystem, like concurrent programming stuff, like a standard one is great, and Akka is also awesome, and collection APIs, and algebraic data type and the pattern matching, traits, anywhere, so whatever you like. It makes us productive more, so very few team members are developing and maintaining the BONX Android application for 2 years. So thanks to Scala, we are doing such a productive work. So, and if you use Scala in server side, obviously there is smaller context switch cost between the client codes and server codes, and you can have some of the common libraries among them. That is great. Okay, then let me show another Android Scala use cases about stateless concurrent programming. Now it's stateless. The concurrent programming is a huge demand in Android as well, because the view modifications must run on UI thread, means main thread in Android, while the heavy computation have to be done in subthreads, because otherwise it causes ANR, application not responding. It kind of looks freezing. Okay, though Android has tons of asynchronous APIs, but generally they are not composable. And Scala offers a better API for it. Like Scala standard feature works very well in Android as well. Because Scala standard features accept the execution context argument in each manipulation. For example, you can specify the execution context for which run on UI thread for on-complete function. Then you can do the heavy computation on this thread pool, and then you do some view modification on UI thread, like this one. I'd call it the UI execution context pattern. So it's pretty straightforward. The UI execution context just delegate a runnable into the activity, which is a class that enables us to run something in UI thread. And so just use a feature as you do in ordinary, and pass this UI execution context argument explicitly into onComplete function. Then you can do some modification in UI thread if it succeeds. If not, you can show just error messages. So with this kind of the advantage, there are not so few Android Scala projects in the real world as well. For something like September original has a comic app Gamma, which are implemented in Scala 100%, is now hitting 6 million downloads. It's huge. And you know, the Scala Days Android application is developed by 47 Degrees, also implemented in Scala, and Macroid. Macroid is an Android Scala framework. That's cool. And it also has some Akka module, so it's worth seeing if you're interested. And it also has a 9 cards home launcher application. And also Scaloid is another famous Scala Android framework. Actually, I do prefer the plain Scala and Akka rather than using framework, but definitely it's worth seeing. Okay. Next, cons of Android Scala. Android have some limitation on number of methods, which would be 64 kilos. However, Scala standard library is a bit too big to be afforded as it is, so it has to be minimized by ProGuard, which is a tool to remove the unused classes or methods, or just use a multidex. Multidex is a kind of runtime loading of the another dex file. So you can use multiple dex files, so you can multiply the limitation of number of methods. And Android doesn't have Java 8 support yet. So Android SDK toolchain still targets Java 6 Plus environment. This means we have to use Akka version up to 2.3.16, which is already labeled as end of life. And so it's about memory, so you have to be a bit worried about wasting. So actually, it's not pretty much critical, but sometimes you need to worry if you are keen on the performance. And obviously, there is no official support by Google nor Lightment, unlike Kotlin, as Google announced last month. Okay, let me go detail of the ProGuard. ProGuard removes unused classes, fields, and methods. In this context, unused means they are not programmatically referenced. This means ProGuard does not understand reflections or conf file like Akka. So you need to specified which class should be kept in the dex file sometimes. If not, you might find some runtime error, like a no class defined error or no such method error. I would say it's a bit painful configuration to use Android Scala. However, you don't need to configure that one from scratch, obviously. In the SBT Android plugin, it provides a default setting for Scala standard library. If you use plain Scala for Android, just use SBT Android. That works fine. And if you want to use Akka, so I prepared ProGuard config for Akka in version 2.3.16. So I tested it in Akka Actor module and Akka IO module at least. And I believe these two modules are the most useful ones in Akka for Android. Okay, then, so let me cover out how to configure it. Voice. In the easiest way is just keep all the classes. I'm not kidding. It's a good enough as a starting point if it's enough smallish. To keep all the things, you can add one liner to ProGuard config, like keep class Akka.wildcard, wildcard. Then you'll want to revisit ProGuard config before you release it into Google Play, or you are hitting the number of methods in your dex. To configure it properly, find and add all classes which are used to the reflection with just grabbing will be the easiest for it. And then you can see some of the conf file like akka reference.conf. And these classes with XQCN will be created via reflection as well. So you have to specify those kind of things as well. With these two, I believe you can almost finish to 99%. However, you might find there's some irregular things which occur, no class defined error or no such method error at runtime. Then, if you find it, please add that classes into your ProGuard config. Finally, the ProGuard config for Akka, it looks like this one. It looks like a bit tedious, but no worries. You can just copy and paste it into your project to use Akka. Okay, let me show some comparison between the keeping all the classes of Akka and keep all Akka classes only referenced by the reflection or conf file in terms of the number of methods and APK size. If you configure it properly, almost both of them get half done. So it's worth doing. However, please be noted that it may vary depending on how many classes you use. Okay, then, as I mentioned, Android doesn't support Java 8 yet, but it will not be in the future. The question is, like the answer would be there. Google is already announced they will support Java 8 in the future, and they released some preview version for it. They are thinking to add some additional tool, which name is Desugar. Desugar tool is just converting Java 8 bytecodes into Java 6 plus bytecodes. So actually, it's still preview version. It doesn't work well with Scala yet. So I would say it's still uncertain if this Android Java 8 support will work. However, Google is trying to provide this kind of tool. So as long as it works fine, I believe the Android will enjoy Java 8 and Scala. If that works, we might be able to enjoy in the future, like a Scala 2.12 or above. So it gets less size of Scala standard library. And remarkably, Dotty will introduce a call graph analysis from Dotty Linker project that eliminates data code. This means it will be smarter than ProGuard. So you don't need to worry about ProGuard in the future, I think. Also, the Akka streams and Akka typed will be available 2.4 or 2.5. Both of them should work well in Android environment as well. And sometimes backup supervision would help you to for supervision customization. And the backup supervisor is small enough, and you can backport it with thread local random. That backup supervisor depends on internally. Please be noted that the thread local random is available from Android 6 or more, or something like that. So you can backport the thread local random from the Android open source project together. Okay, about memory management. Actually, Android DC is not so bad, but sometimes you need to worry about the memory allocation and object creation, as you do in JVM. So, for example, array map or other higher functions box a very primitive type element because they are not specialized. So, Yoshida-san, the Sure case no box library works great for it, and use ring buffer would be option, and byte string in Akka util works well for concatenation slicing of the byte array. And sometimes it will be a good option to use mutable object within limited scope. Okay, then next, some of you might think, why not use Kotlin? It's already official language for Android. At first, I would express my congratulations for Kotlin. It is accepted. That is great news for JVM language. And I would say Kotlin is still great for Android in terms of the gel size of the standard library, which is far smaller than Scala's one. And obviously, the Kotlin is developed by JetBrains. That's why Kotlin has great integration with IDEs. However, I still feel the big advantage in Scala lang functionality and ecosystem like Akka. So, what if Kotlin is already officialized when I start developing a BONX application? I still use Scala for it because it will be much easier to use Akka rather than just creating my own actual system or something like that. Okay, the conclusion, the Akka model works very well in some Android application, especially in the stateful concurrent programming context. As well as, it will be great if you need resiliency even in client code. So it's not a very popular situation, but sometimes it works very well. And our BONX app fully leverages Akka for its VoIP system. Okay, thank you very much.